maximum breaker amperage for a 100 amp service panel is 100 amps. This means the total sum of the amperage ratings of all the individual circuit breakers in the panel should not exceed 100 amps. The 100 amp rating signifies the maximum amount of current the service entrance conductors and the main breaker can safely handle. Overloading the service can lead to overheating, damage to equipment, and potentially fire hazards. It's crucial to understand how the total load is calculated and distributed across the various circuits within the panel. While the sum of the individual breaker ratings might exceed 100 amps, this doesn't necessarily mean the service is overloaded. This is because not all circuits will be operating at their maximum rated current simultaneously. A load calculation determines the actual demand on the electrical system. This calculation considers the types of loads, their usage patterns, and any diversity factors that allow for a reduction in the calculated load. Diversity factors recognize that not all appliances and devices will be drawing their full rated current at the same time. For example, a kitchen might have several 20 amp circuits for appliances like a microwave, toaster, and blender. However, it's unlikely that all these appliances will be operating simultaneously at their full capacity. The load calculation takes this into account, resulting in a lower overall demand than the sum of the individual breaker ratings. However, it's still important to ensure that the load calculation remains within the 100 amp service rating. If the load calculation exceeds 100 amps, it indicates that the service is undersized and needs to be upgraded. Upgrading the service involves replacing the service entrance conductors, the main breaker, and potentially the entire electrical panel with components that can handle a higher amperage. This is a significant undertaking that should be performed by a qualified electrician. When determining the appropriate breaker size for a particular circuit, it's essential to consider the ampacity of the conductors. The ampacity of a conductor refers to its current carrying capacity, which is the maximum amount of current it can safely handle without overheating. The National Electrical Code, or NEC, provides guidelines for determining the ampacity of conductors based on their size, insulation type, and installation conditions. It's crucial to select a breaker size that does not exceed the ampacity of the conductors. If the breaker is too large, it may not trip in the event of an overload, allowing the conductors to overheat and potentially cause a fire. For example, a 14 American wire gauge, or AUG, copper conductor with type THHN insulation typically has an ampacity of 15 amps. Therefore, it should be protected by a 15 amp breaker. A 12 AWG copper conductor with type THHN insulation typically has an ampacity of 20 amps and should be protected by a 20 amp breaker. A 10 AWG copper conductor with type THHN insulation typically has an ampacity of 30 amps and should be protected by a 30 amp breaker. These are general guidelines, and the specific ampacity of a conductor may vary depending on the installation conditions. It's always best to consult the NEC for the most accurate and up-to-date information. In addition to considering the ampacity of the conductors, it's also important to consider the rating of the devices and appliances connected to the circuit. The breaker size should be selected to protect both the conductors and the equipment. For example, a 15 amp receptacle is designed to handle a maximum of 15 amps of current. Therefore, it should be protected by a 15 amp breaker. A 20 amp receptacle is designed to handle a maximum of 20 amps of current and should be protected by a 20 amp breaker. Large appliances, such as air conditioners, water heaters, and electric ranges, typically require dedicated circuits with specific breaker sizes. The manufacturer's instructions for the appliance will specify the required circuit size and breaker rating. It's important to follow these instructions carefully to ensure the safe and proper operation of the appliance. When installing or modifying electrical circuits, it's always best to consult with a qualified electrician. A qualified electrician has the knowledge and experience to ensure that the work is performed safely and in accordance with the NEC. They can also help you determine the appropriate breaker sizes for your specific application. Furthermore, it's important to regularly inspect your electrical panel for any signs of damage or overheating. Look for loose connections, discolored breakers, or any unusual smells. If you notice any of these signs, contact a qualified electrician immediately. Regular maintenance and inspections can help prevent electrical problems and ensure the safety of your home. Remember that electricity can be dangerous, and it's important to take precautions to protect yourself and your family. Never attempt to work on electrical circuits unless you are qualified and have the proper safety equipment. Always turn off the power to the circuit before working on it and use a voltage tester to ensure that the circuit is de-energized. By following these guidelines, you can help ensure the safe and reliable operation of your electrical system. In summary, the maximum breaker amperage for a 100 amp service panel is 100 amps. This means that the total sum of the amperage ratings of all the individual circuit breakers in a panel should not exceed 100 amps. While the sum of the individual breaker ratings may exceed 100 amps, the load calculation should remain within the 100 amp service rating. It's important to select breaker sizes that are appropriate for the ampacity of the conductors and the rating of the devices and appliances connected to the circuit. Consult with a qualified electrician when installing or modifying electrical circuits and regularly inspect your electrical panel for any signs of damage or overheating.